Welcome to this explainer. We are jumping right into the thick of it today because we're tackling a massive topic for anyone building or managing hardware for artificial intelligence. We're going to dive into exactly how to properly cool an always-on AI workstation. And you know what? To do that, we're going to start by completely throwing out pretty much every piece of traditional gaming PC advice you've ever heard. If you've spent any time looking into PC building, you know the internet is absolutely flooded with cooler reviews. But as our source material today makes incredibly clear, almost all of that advice is answering the completely wrong question when it comes to an AI context.
To truly understand AI hardware, we have to start with this exact quote from our source material, because it represents a massive paradigm shift. When you're building a machine intended to run local large language models, train networks, or generate images, the primary goal isn't about setting benchmark records. The primary spec is that this machine needs to run 24 hours a day, 7 days a week, completely unattended. And once runs 24/7 becomes your core requirement, the most important question stops being which cooler gives me the lowest absolute temperature and immediately shifts to which one will still be working in 3 years without me thinking about it.
And this brilliantly illustrates the exact difference in our cooling priorities. Think about traditional gaming PCs for a second. Gaming guides optimize for peak temperatures. They're chasing those benchmark numbers to squeeze out a few extra frames per second during a 2-hour gaming session. But then, look at AI inference rigs. These machines are entirely different beasts. An AI rig is often sitting in a closet, humming away, running massive batch jobs for days on end while you sleep. When a machine is running flat out, unattended, in the dark, total reliability isn't just a nice-to-have feature, it's the entire ballgame. A cooler failure during a 3-day training run doesn't just crash a game, it ruins days of expensive compute time.
Section 1. Why air cooling wins. Air cooling isn't just some budget compromise for people who can't afford liquid, it is the absolute reigning champion of long-term reliability. And the reason comes down to this single digit, 1. That represents the exact amount of moving parts you're going to find in an air cooler. It's literally just the fan. And in the world of 24/7, always-on engineering, having only one moving part isn't a limitation, it is an air cooler's absolute greatest superpower. The fewer parts you have moving, the fewer parts you have that can potentially fail while you're fast asleep.
Because there's only one moving part, the reliability skyrockets. Beneath that single spinning fan, the heatsink itself is just a solid block of metal. That's it. It's dumb metal. There is absolutely nothing inside it to leak onto your expensive GPUs, nothing to slowly evaporate over time, and no internal motors to seize up. This simplicity makes an air cooler practically immortal. If that one moving part, the fan, does happen to fail, swapping it out takes a couple of minutes and costs you a few bucks. The confidence in this design is so high that premium brands like Noctua famously warranty their air coolers for up to a full decade. The metal block itself will easily outlast every single other component in your system.
Beyond just being practically immortal, there are several cascading benefits to this setup. First up, air cooling brings a meaningfully cheaper overall cost. Second, the maintenance is trivial. You occasionally wipe the dust off the metal fins and maybe repaste the CPU every few years. That is the entire maintenance schedule. But the third point is perhaps the most crucial for AI workloads: raw capability. People often underestimate air, but a high-end dual-tower cooler, like a Noctua NH-D15, can easily dissipate 200 to 250 watts under sustained tasks. It easily rivals mid-sized 240mm liquid coolers, keeping massive chips like Intel i9s or AMD Threadrippers well under 80 degrees Celsius during long, heavy workloads.
Now you might be wondering about the noise. If your rig is sitting right near your desk, this detail is absolutely vital. What's really interesting here is the surprising fact that air coolers are often perceived as quieter. A top-tier air cooler under load typically produces around 40 to 45 decibels of noise. A liquid cooler, or AIO, operates slightly louder, around 45 to 55 decibels. But it isn't just the volume, it's the type of noise. Liquid coolers have a constant, low-frequency pump. Air coolers don't. They completely lack that annoying mechanical drone of a liquid pump running 24/7.
Section 2. The Specialized Challenger. Liquid AIOs.
So, does liquid cooling have a place at all? Absolutely. But we have to view all-in-one liquid coolers not as bad hardware, but as highly specialized tools with invisible clocks running on them. The biggest clock? The pump. Unlike the solid block of metal on an air cooler, an AIO relies entirely on a mechanical pump to move liquid over the processor. This pump is a textbook single point of failure. The typical lifespan of this mechanical pump is roughly 5 to 7 years. Because AIOs are sealed loops, they're completely non-refillable and non-repairable. When that pump inevitably dies, the entire cooler is dead, and you have to throw the whole thing away. The crucial point is that running a pump 24/7 for AI inference is the exact heavy-duty cycle that accelerates this wear and tear, making an AIO a temporary asset in your machine rather than a permanent one. And honestly, the pump isn't the only invisible clock ticking away. Even if the pump runs flawlessly, the coolant liquid actually slowly permeates and evaporates straight through the microscopic pores of the rubber tubing at a rate of roughly 0.5% a year. So over 3 to 5 years, the loop loses effectiveness. On top of that, the internal seals and rubber tubing harden and deform under constant high heat. And while incredibly rare today, catastrophic leaks are still physically possible. All of these factors combined mean that choosing an AIO will roughly double or triple your total cost of ownership for cooling over the life of your workstation, simply because you are going to have to buy a replacement cooler eventually.
Section 3. When to choose liquid.
Now, we certainly aren't bashing liquid cooling here. Let's look at exactly where a massive 360mm liquid cooler wins outright and air simply cannot keep up. First, peak thermal headroom. If you're running the absolute hottest top-tier overclock chips continuously pulling around 360 watts of power, air will struggle. You need the thermal mass of a large AIO. Second, physical space. In dense multi-GPU builds, a giant 60mm tall air tower might physically block your RAM or just not fit in the case, and AIO's compact CPU block completely sidesteps this problem. And third, brilliantly, heat isolation. If your rig is in a hot, non-climate controlled room, an air cooler just recirculates that hot air inside the case. An AIO moves the heat via liquid to a radiator and forces it directly out an exhaust vent, keeping your GPUs breathing way easier.
Section 4. The head-to-head comparison.
So let's synthesize all this data into a direct, side-by-side showdown. When you look at the trade-offs, it's incredibly clear. Reliability and lifespan, air gives you a decade plus with basically 0 fail points, while the AIO limits you to 5 to 7 years thanks to that mechanical pump. But for peak headroom, air is great, sure, but the 360mm AIO is the absolute best for extreme heat. When we talk noise floor, air is actually quieter, lacking that constant pump hum. For heat handling, air dumps it inside the case, while liquid smartly exports it right out of the room. And cost? Air is substantially lower over the system's life. This definitive showdown explicitly shows how the trade-offs heavily favor air for those 24/7 set-and-forget rigs, while reserving AIOs strictly for the physical and thermal extremes.
Section 5. How to decide. The order of operations.
Okay, so how do you actually decide for your own build? Well, we are going to use a highly actionable decision tree, and you must walk these steps in this exact order. Step 1. Does your case physically fit a big dual-tower air cooler? If you're building a dense rig and the answer is no, stop right there. You must buy an AIO. If yes, move to Step 2. Is your CPU a top-tier chip, like a flagship i9, running flat out under maximum load? If yes, you need the liquid headroom. If no, move to Step 3. Is the rig sitting in a hot, non-climate controlled room where isolating heat out of the case is absolutely critical? If yes, buy an AIO. But if you answer no to all 3 of those specific edge cases, you drop down to Step 4. You default to air cooling. Let your actual situation dictate the hardware.
But hold on, before you finalize that decision, we must remind you of an essential tip from the source material, known as the pillar rule. Undervolt and power cap your CPU first. This is a total game changer. By simply going into your system settings and capping the maximum power draw of your CPU, you immediately reduce the heat output with barely any loss in AI performance. Doing this one simple software trick often turns a stressful, "do I need liquid cooling to survive?" panic into a very comfortable, "an air cooler is plenty" reality. Manage the heat generation first before you go out and buy the heat dissipation.
Section 6. What's next? Pumpless liquid cooling.
Before we wrap up, let's take a surprising glimpse into the future of cooling technology. Have you ever heard of thermosiphon technology? Devices like the Ice Giant Pro Siphon Elite use a sealed liquid loop, but they have 0 moving parts. It uses the physics of evaporation and gravity to move heat, completely eliminating the need for a mechanical pump. Right now, it's capable of matching the performance of a massive 360mm AIO. While this specific tech is pretty niche and fairly pricey today, it represents a massive leap. It could eventually offer liquid-class headroom with air-class, single point of failure-free reliability. It's definitely something to keep your eye on.
And that brings us to the end of our explainer. As AI models continue to grow ever more demanding, and as the silicon power in them just keeps running hotter, you have a fundamental choice to make. Will you let gamer marketing dictate your workstation, risking your expensive, unattended workflow just to achieve peak benchmark numbers today? Or will you look at the reality of 24/7 compute and choose the cooler that is guaranteed to survive 3 years running quietly in the dark? Let your actual workflow be your guide. Thanks so much for joining me today, and I hope this helps you build a phenomenally reliable machine.